Hi, Dr. Zatorre. How are you?
I'm good. How are you?
Thank you for joining me with this. I was suggested to look into neuroscience and music.
Hmm.
I looked you up and I was very impressed with your credentials, and I want to thank you sincerely for your time. The first thing
Great.
I wanted to ask you is how you got into the whole process of learning about neuroscience and
Sure, yeah, I
what.
often get asked that question, and as I think I have pointed you, I recently published a book about the neuroscience of music, and in that book, in the preface, I give a little bit of a personal history because people are often wondering how did I get into this, because at the time that I started doing this, it was. Oh, I don't know, late 1970s, early 1980s. Um, there was no such field as, music and neuroscience.
Right.
It really didn't exist. So it was a bit of a risky proposition. But my motivation was on the one hand, when I was a student, I was always very interested in science. Science was sort of the thing I wanted to do. Um, and so I was taking, physics and math courses, as well as biology and psychology and so on. Um, but then at some point, when I was probably 13 or 14, I had a real epiphany, a musical epiphany, um, where I suddenly started to listen to music that was, much more sort of challenging than the pop music that I had been exposed to. Um, and I really found it, sort of life-changing. It was really a turning point. And on the one hand, on a personal level, I wanted to study music, which I did. I actually did a whole degree in music at the same time as I was doing my degree in psychology. Um, and I wanted to learn to play music and so forth. But the scientist side of me was wondering, well, why does music have this effect? Like, why is it so amazing to me, but not only to me, but to, millions of other people? Um, and so that sort of set me on that path. And at the beginning, there was nowhere to turn really because there was hardly any research being done in that area. But slowly, I kind of built it up, little pieces here and there. And I was aided a lot by people who were very sympathetic. My PhD supervisor was a guy who worked on uh, speech, basically, the processing of speech sounds. And I sort of convinced him, hey, if you study speech, why don't we study music? And he was very open-minded. He said, well, I don't know anything about music, but if you want to try your hand at it, let's see how far you can take it. And so, slowly but surely, we kind of built it up. And then other people, in other places had similar ideas at around the same time. And so we sort of slowly built up a community of people. And now what's really nice is that, there are many labs throughout the world that are interested in the neuroscience of music. We have, a conference that we hold every couple of years that attracts 400 or 500 people. Um, and there's enough interest that I was able to write this book and so forth. So I think it's been a pretty interesting ride.
Your book that you mentioned, From Perception to Pleasure, it delves into how our brains experience music. Can you give us a simple overview of your findings?
Yeah, sure, absolutely. So the full title is From Perception to Pleasure: The Neuroscience of Music and Why We Love It. And the title sort of says it all. So the focus is on, how do we perceive music and why do we get pleasure from it? And that's why it's from perception to pleasure. And basically, the book is divided into two parts. The first few chapters deal with the perception part, which is the more hardcore neuroscience aspect of the book. I talk a lot about the circuitry in the brain that allows us to perceive different types of sounds, how we are able to put those sounds together into patterns, how our brains recognize those patterns, and also the act of producing music, because you can't perceive music unless someone is producing it, right? And so we also have specialized brain circuits that allow us to control the larynx, of our voice to produce songs. Um, and also, we have very fine control over our fingers and other body parts that allow us to produce music with musical instruments. So that's sort of the first half. But then that doesn't explain why we love music so much. And so the second half really is an attempt at explaining that from a neurobiological perspective. And so I go through the parts of the brain that are relevant for the experience of pleasure, which scientists call the reward system. It's a set of nuclei in the brain that respond whenever there is a very powerful stimulus that is somehow important for our survival. So typically, this has been studied for years in animals where they would typically use food or water as the stimulus, because if you are hungry and you get food, that's incredibly rewarding, right? We seek the food if we're hungry. If we're thirsty, we seek out water. And it's also similar for things like sexual stimulation, right? We seek out sexual stimulation because it's necessary not for the individual. Some people opt not to be sexually active, but for the species to survive, you need to reproduce, and reproduction requires sex. So,
Oh, are you saying
um,
that's in our DNA as well?
sure,
Okay.
absolutely,
And how did
absolutely.
you come up
Uh,
with these findings through like what studies have you done, if you don't mind me asking?
Yeah, yeah. So, I mean, the reward system is not just humans, right? It's most animals on Earth.
Right.
You need, in order for the animal to survive, it needs to, you know, find food, find water, find shelter so it
Produce.
doesn't
Yeah.
uh, avoid predators, and reproduce.
Mhm.
That's what you need to do. So all of us are biologically uh, driven, to do those things. Otherwise, we wouldn't be on the planet. We would have died off.
Right.
And the question that I addressed starting some 20 years ago was, okay, we have all these mechanisms in the brain for survival, but what about music? Music isn't exactly needed for survival. I mean, you can live without it. It won't kill you if you don't get it. You might be unhappy or whatever, but it's not really exactly the same. And it's not a chemical, like drugs, by the way, also act on the reward system, which is why they're so dangerous, right? If you get addicted to something like cocaine or amphetamines, they act directly, chemical action directly on the reward system. And so, yeah, they might get you really high, but it comes at a cost. But again, music is not a chemical, it's a pattern of sounds. So we started doing experiments using brain imaging technology where we can actually see the activity patterns inside the brain of healthy, normal people while they do different things. And we got them to listen to music that they enjoyed listening to. And we saw that many of the same regions of the brain that are involved in these biologically driven rewards are also indeed um, active during music listening when the music is pleasurable.
Amazing.
And this is sort of a kind of a surprise, because it opened the door to a whole different understanding. Previously it was thought that the reward system was only for these biologically driven things, like you said, that are in our DNA. Um, but music really is quite different in the sense that, as I mentioned, it's not directly necessary for survival, and it's also very culturally conditioned, right? The music that different people like depends very much on their culture, where they came from, their upbringing, their peer group, all kinds of things. So this means that now we are trying to understand how is it that the reward system is active when we hear music. And in the book, basically, the answer is that there are two systems in the brain. One is the perception system, one is the pleasure system. And when they interact, when they exchange information, connect with each other, that's when you get pleasure from music. And so that's the bottom line of the argument that I develop based on a lot of experiments that we've done. And that's why we get pleasure from music, and probably why we get pleasure from other things that are more abstract, not only music, but think of visual art or think of movies, think of stories,
Entertainment in
think
general,
of
maybe.
games, right? Like, why do we play games? Like, humans play games now in modern times. We play video games. Ancient humans played games with, little stones,
Mm.
right, on a board, but they still entertained themselves. Um, and these are all things that aren't essential for survival, but they do play a role in our well-being and also in our social world, right?
Mm.
Music and games and stories, they're all things we share with other people, right? They
Totally.
sort of help to define ourselves within a group, right? We share certain things within a culture. You share certain ways of communicating, certain music, certain stories. In modern times, we have film, we have a lot of technological innovation, but it's all basically the same. It's somehow these perceptual patterns that engage the reward system. So it all comes down to biology ultimately, but the biology is not, it's not a deterministic biology. Sometimes people say, oh, well, if it's in the DNA, that means that it's all preordained, it's all preconditioned. No, it's not. It doesn't work that way. The DNA is, builds your reward system, right? If you have a if you have a problem in your genetic in your genome, your reward system will be dysfunctional, and that usually leads to very serious health problems. Um, but the reward system receives inputs from these other parts of the brain.
Now,
In the case of music, it receives inputs from the auditory part of the brain, and we derive pleasure from it. And, that's a remarkable thing, really, when you stop to think about it.
is that similar to like an athlete that where they get endorphins from like running or exercise?
Yeah, I think
That
there
is
are,
that actively creating the endorphins in your brain, like
yeah,
when you
it's
listen
an,
to music, is it the same thing, the same kind of a reward system
I
you're
wouldn't
mentioning?
say, yeah, that's a very interesting question. I wouldn't say that it's exactly the same thing because the endorphins have to do with the athletic action. If you're simply listening to music, you know, um, you don't necessarily have endorphins. You do have dopamine.
Yeah.
That's the main that's the main molecule that mediates music reward.
Okay. Dopamine.
Um, yeah, so it's dopamine. We've actually demonstrated that directly by manipulating the amount of dopamine, pharmacologically by giving people drugs that either increase or decrease their dopamine,
Okay.
and we see that the musical pleasure increases or decreases
Now,
as a function of what
now
we give
getting
them.
back into the athletic, I'm sorry to interrupt, but
Hmm.
now I was an athlete before I became a musician. And
Uh-huh.
now, as an athlete, I think I had the same ideas when I approached playing guitar, for example, and that it was more like athletic to me. And
Hmm.
now that gets back into the endorphins. Would you say that as performing, that's a form of athleticism, or that would also not only affect the dopamine but the endorphins as well as a performer?
Hmm.
Because at times I practice and practice and practice until I felt like like I was Hercules,
Hmm.
and
Yeah, yeah.
so
It's a very interesting question. I think you may, I don't know of any evidence for it. I'm not sure anyone has directly studied the question, but it is certainly true that musicians, um, because of their physical training, often are like athletes,
yeah,
right? Think of an opera singer belting out, songs at the top of their voice for 3 hours straight.
right,
That's a tremendous feat of physicality, right? Or the drummer in a band who's,
absolutely.
whacking at those drums. Like, it's wild, when you have to do that. So you do have to be in good physical shape. Does that action release endorphins, which then enhances the musical pleasure? That's a really good question. And I am not aware of research that has looked at it, but it would make sense to me if if there's some interaction there between the action and the
Yeah.
pleasure.
Yeah, I think that's, that's awesome. That's why I'm like so excited to get to talk to you. I have like a lot of questions for you here.
Yeah. I can say
Um,
one more thing about the movement, which I think is also relevant, is that music and movement are very closely linked, and you have the phenomenon of dancing, which is found in all human cultures, by the way. Every culture has music, and everyone also dances to music. As far as I know, there are no
at least
cultures where
bangs
people
their head
just
or some
they
kind
move in some way. They move in some way that's in time to the music, right? And babies do this too, by the way. Like, they don't have to be taught. They will move when music is played to them. It seems to be something natural that they have.
you
And
understand.
so,
Do you know the scientific, is there a scientific study as to why that happens? Why it's like a
yeah,
natural
well,
like that?
it's yeah. So the theory that has been developed, and I do talk about this in one of my book chapters in chapter 4, in particular. So it turns out that the part of the brain that is related to hearing is very tightly connected to the part of the brain that's related to movement. And this is in part has to do with speaking, because when we speak, we're making movements of our lips and our tongue and our larynx, and that produces sound. But it's also linked more generally to the fact that many movements create sound, right? So when you walk, your footsteps make a noise,
Yeah,
and if I clap my hands, that also makes noise. And so there seems to be a very tight coupling between the motor part of the brain and the auditory part of the brain. And so when you execute certain motions, sounds are produced. And when you hear certain sounds, it therefore engages some of those same motions.
it's very
And this is
interesting.
one of the ideas about why people move to music is because there's a kind of facilitation of the sound, and it just feels natural. Again, of course, you can train to become, a professional dancer,
Right.
but if you look at a toddler, right, when it's about 2 years old, it's going to start dancing
Mm.
unless there's something, going on with the child.
Right.
Um, Most kids are you don't need to show them how to dance. They know they don't need to be it doesn't need to be explained. It's kind of like walking.
Mm.
It's pretty natural. They start walking at a certain age and they start dancing at a certain age. It's kind of probably built into the connections in our
Yeah,
brain.
that's very interesting. Now, you've explored the concept of brainwave entrainment, also known as brainwave synchronization or neural entrainment. Can you explain
Mhm.
that a little more in simple terms?
People often think there's some kind of a black magic involved when you use the word brainwave, and people think of all kinds of strange things, but it's really not. There's no magic involved. It's very simple. Um, Basically, your the nerve cells in your brain that are called neurons, they're active, right? It's called firing. They have an electrical discharge, and that discharge happens on a quasi-regular basis. In other words, it doesn't just fire once. They usually fire, let's say 5 times in a second. It's like beep, 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 like that. And if they all fire in synchrony, if you have, 10,000 neurons that are all active at the same time, it produces a so-called brainwave. All that means is that if you put a wire on your head and you look for the fluctuations in electrical energy, you see that those fluctuations go up and down at a certain frequency. It could be 5 times a second, could be 10 times a second. It goes up to 30 or 40 times a second.
Now, I know there's been
Um,
studies on like alpha, beta, data,
exactly.
data or whatever, and certain patterns or sound waves that affect these different states. And is that where you're going with this? I'm sorry to
Yeah.
again.
Yeah. Well, you were asking me about, to explain what brainwaves are.
Yep.
So that's all they are. It's just a synchronous activity of groups of neurons, right? It isn't any kind of black magic or anything else. And then, different parts of the brain have different frequencies. That's, they're sort of idling at different rates. Um, and in turn, those frequencies can be entrained to an external stimulus. So there's what we call endogenous oscillations. That's when you're just sitting alone without any input, and your brain is idling, and you see these frequencies. But then, if an external input comes in, let's say it's a drum rhythm, for example, well, it can entrain those brain waves. And all that means is that the um, the brainwaves start to occur at the same time as the drum beat, right? So they align with each other.
Very
Um,
interesting.
so when that happens, that's also related to this phenomenon that we were just discussing of movement and dance and so forth, um, because there are certain rates, certain frequencies that are, closer to brain frequencies than others. And if you look, for example, at music from different cultures and so forth, excuse me, they generally have a beat frequency which is in that range of, somewhere between, I don't know, 2 and 8 hertz, 2 and 8 times per second. Because if it's faster than that, you can't really follow it because your brain won't entrain to it. And if it's slower than that, you can't really follow it either because it's too slow. And so again, your brain waves won't entrain to it.
How can music be used therapeutically to improve mental and emotional well-being?
Yeah, that's a great question. There are many different ways in which music can be used therapeutically. And there's a whole specialty known as music therapy, where people are trained to give a musical intervention for many different disorders of many different kinds. Um, and what I think is very good is that I talk a lot to people who work in music therapy, and they are very interested in the research we do because they tell me, well, you're doing the science part, and so we can learn from that to develop better applications to our patients. So, I'm not a clinician. I don't work with patients. I just do my work in the laboratory. But it's very, rewarding to me that people who do, they're in the trenches, they're working with patients who are suffering, and they're able to use some of the knowledge that we've developed and my other colleagues in the field as well to help them develop better applications.
Yeah.
We One of the ways in which um, the work we've done has helped is this whole link to the reward system and to dopamine, because there are many disorders where the dopamine system is not functioning. A very good example is Parkinson's disease. So Parkinson's disease is a disorder. It's very prevalent all over the world, um, and people tend to get it in older age groups, 50, 60 and above. And it's a depletion of dopamine. So their dopamine system sort of runs out of dopamine.
Wow, that's
And
very
those,
interesting.
yeah, and I don't know if you've ever seen a Parkinson's patient or
Yes, I
uh, talked to them. It's a very common disease, unfortunately. And one of the problems that they have is a lack of pleasure. They it's not the most it's not the most obvious thing. If you watch someone with Parkinson's, they have a tremor.
yeah.
That's what you see, right? But if you talk to these patients, they say, "Yeah, the tremor, I don't like it. It's really bothersome." But what's really bad in my life is that I no longer enjoy things. I used to like to, watch movies. I no longer enjoy that. I used to like to be in, parties and with my friends, and now I don't get any enjoyment out of that. It's very sad.
Yeah.
They're depressed. And we think it's because of the dopamine that is no longer, um, working
Right,
correctly
or at
in the
least
reward
that's one
system.
area of it, right?
Correct. That's one area. It's
Yeah.
it's more complicated than that.
Yeah.
You're
Because
absolutely right. So what we've been working on, we have a collaboration with some former students of mine in Tel Aviv. And what they're doing is they've developed kind of a neurofeedback app for eventually to be tried with Parkinson's patients. So far, it's still experimental. But the idea is that we play music to people and we monitor their brain activity at the same time. And then we make the music get better and better sounding the greater their brain activity is. As we measure the brain activity, it feeds into the algorithm that generates the music. So the better your activity is, the better the music sounds, which makes your brain activity higher again, which makes the music sound better. It's a positive feedback loop that goes back and forth. And we're trying this out, and it seems like um, even in people who do have some disorders of the dopamine system, we can help to kind of trigger that activity, which would otherwise be absent. So that's, one way in which we're trying to actually apply our knowledge in hopefully what would become a fairly easy kind of application. Because you could imagine in the future, this is not a drug, this is not anything that is dangerous in any way, and it's cheap too, because all you would need is, I'm thinking of an ideal future where you just download an app that takes your favorite music and gives it to you based on your brain activity. And wouldn't that be cool if we could do that?
I think from my own personal experience that music's been very therapeutic in a lot of ways. Uh, for
Yeah,
example,
absolutely, absolutely. I mean,
helping
if
you get through certain things throughout life and give them the strength in
absolutely,
areas.
yeah. I mean, people have known this, right, for millennia. I mean, that's why music exists, right? Is because it helps regulate your emotions, right?
Absolutely.
If you're if something great has happened, right, and you want to celebrate, well, you put on, loud party music and you dance to it, right? If you won $1 million in the lottery, that's what you do. But if, a loved one has just passed away, that's not the music you're going to listen to, but you're going to listen to music for sure. You're going to listen to music maybe to make you reflect on your sadness, or maybe music that they used to like to make you remember, what they were like. Um, so, music is there to help you in at every stage of life and in every emotional state. It's why we always have music with ceremonies, right? Uh, I've never been to a wedding that didn't have music. Um, right? If you attend any, I don't know, any event, a rally or a patriotic event, there's always music, right? If you go to a party, there's always music. Imagine going to a party with no music. That would be the most boring party ever.
That gets into I think that gets into the question about the music and how it triggers memory. And
Yeah.
that's a
Hmm.
very interesting thing because just to elaborate a little bit on my own, when I went to college, when I first went to college, before Musicians Institute, for example, taking my prerequisites or whatever, and I thought to myself, I could look at a piece of music and visualize it and memorize it note for note, in my head. Like I
Hmm.
closed my eyes and I could see that.
Hmm.
And I thought to myself, if I can do that with music, I can do that with anything, you know. And it's taking that attitude and applying that toward different areas of study. And that's what I did, once I went to college. It's very interesting how that can influence other areas of study,
Hmm. Hmm.
increase your confidence, your self development, um,
Sure.
your discipline, your focus,
Yeah.
and
Yeah.
a lot of areas like that.
Yeah. No, I mean, I think music has a lot of benefits that are like beyond the music itself,
Yeah.
right? So one of my former students um, is she was from France and she's now back in Paris, and she's working with the Paris Philharmonic Orchestra because what they have is a program for disadvantaged kids all over France. And what they do is they take these kids who are often they're, kids from very poor backgrounds. A lot of them are immigrants to France from like North Africa and places like that. And these are kids who, they have a lot of social problems, right? They are engaged in drugs. They join gangs. The girls get pregnant when they're barely teenagers. And so what they do is they've been teaching them to play music in the schools, not so much so that they become great musicians, but so that they learn all of the things you were just saying, self-confidence, so that they're proud of something that they do, so that it's a social event. They're doing it with their
Right.
peers,
Yeah.
right? There's a discipline behind it. You have to practice. You have to show up for the rehearsals. And what they're finding is that these kids do much better, right? The dropout rates from school, you know, are improved. They they tend to stay with the music. They really like it. Um, their drug use goes down. There's a lot of these benefits that have to do, um, I think, with a lot of different aspects of music, and especially I would emphasize the social aspect
Oh,
where you're
absolutely. Like
you're
it was
playing
more,
music with other people, right?
yeah,
And
or even entertaining, you're having to interact with other people and share that,
yeah,
and it helps develop your social skills, I believe,
absolutely.
you know?
Yeah. Yeah.
And
And we were talking about entrainment before. There's a really interesting effect that happens. People have done experiments on this, that if you play music with other people, um, your brain will entrain with that other person. So your brain and that person's brain will both be like literally on the same wavelength, right? And when you do that for, hours at a time, what happens is that you form a social bond with the other person and you trust them more, and you become closer to them in a way that wouldn't be the same if you did some other activity, like if you I don't know, like playing games, for instance, doesn't do it, probably because the gaming situation is more competitive. And also because your movements aren't necessarily synchronized, whereas when you're playing music, you have to synchronize your movements, and that
it's
gives you
like
that
being it's
entrainment.
it's like a band, you eventually get good from practicing with each other enough to where you become like a unit.
That's
And
right.
you kind of, know where everybody's going to go,
Yeah,
and you're
yeah,
on the
yeah,
same wavelength. So that's
yeah,
absolutely that's very very interesting.
yeah,
So obviously, and this is kind of sidetracking a little bit, but obviously music's very important in self-development, which I know that there's been a less support of music in schools, and it's been more focused on like math and science, which, technically music is mathematical and it's also a science. So
yes,
that's why I think it's ridiculous that, that it's not considered as important as other, um, prerequisites or whatever in
yeah,
schools. And
yeah, yeah. It's too bad that that's being lost. I think it's sort of short-sighted
it
because
doesn't make any sense to me because again, it helps in your self development a lot better than a lot of
yeah, and you're
areas.
you're short
Yeah,
you're shortchanging the kids because this is an experience that will be beneficial to them throughout their lives,
creativity.
and and you're not giving them that experience early on, and it's much harder to catch up when you're an adult, right? So I don't know, but why wouldn't you want your kids to not just your kids, but in general, children to get the benefit of this kind of activity? And it's not for everyone. There are some people who don't respond much to music. We've actually studied them, and that's kind of interesting. Um, but the vast majority will indeed respond very strongly to music. So
Now back to music triggering memories. Like for every era of my life, I can think of a song, and I
yeah,
can think of exactly how I felt at that moment,
yeah, yeah,
thinking everything. So how can that, be beneficial, in future study or in areas as far as memory to improve memory?
hmm hmm Yeah, well, I think the reason it happens goes back to the reward system.
Mhm.
So, we talked about the reward system in terms of um, important stimuli for survival, like, food or water. Um, but it's also very strongly linked to memory for the simple reason that imagine you're, you know, an animal trying to survive in the wilderness. If you find food in a particular spot, you're not only going to eat the food, you're also going to remember that, oh, wow, this is where I can find food, or this is where I can get water. So it triggers the memory system because it's basically a salient event. This is something, very good that's happening. I better remember everything I can about it so that I can get back to it later. And the neurobiology has been extensively studied. There are connections between the reward system and the hippocampus of the brain, which is one of the principal memory regions. So you get this facilitation of memory. And I think that's why you have this phenomenon that you described, which is so common, that if you hear a particular song, it immediately reminds you of a certain event. And vice versa. If you think of a certain event, you immediately remember what the music was that was associated with it. So, I think this is part of really understanding how memory works. So if we want to be able to treat, for example, diseases that affect memory, like Alzheimer's and so many others, um, we really need to understand exactly how this super complicated brain system works so that we can develop better therapies. And indeed, there are some people who are working with music to try to get memories from um, patients with dementia, especially Alzheimer's, who often actually will respond to music, even though they don't respond to almost anything else. It's not uncommon. It's not every patient, but it's not so uncommon that if you play meaningful music to one of these patients, they will respond emotionally. Sometimes they'll laugh, sometimes they'll cry, sometimes they'll get up and dance. Um, and it's triggering something in their brain that's somehow still there.
It reminds me of this thing I saw about this guy that like had Alzheimer's or whatever, and he was a famous classical pianist. Okay,
hmm
and he'd forget that he talked to you 2 seconds after you left, but he'd play a whole classical piece with
Yeah,
flawlessly, note for note. And I always
yeah,
thought that
yeah.
was very interesting how that somehow triggered his memory in that area.
hmm
You said that there's been studies that have been done on this in that area. Are you familiar with any specific studies or?
It's an active area of research because, of course, Alzheimer's and other dementias are uh, are very prevalent, and in many parts of the world, um, in Japan, in Europe, and in North America, the population is getting older and older. So you have more and more people who are suffering from dementia, and there are no drugs for it, right? So if you could enhance the lives of these people using something as simple as music, it's certainly worth exploring. Nobody is saying that music is going to cure Alzheimer's, right? That's not on the table. That's not what we're talking about. What we are talking about maybe making life a little better for those folks. And who knows, maybe in the future we can also enhance memory in some ways. So it's a very active area of research. It's I think it's still somewhat in early days.
So, what are your plans for the future research for?
Yeah, I mean we're doing a lot of different things. I mentioned the project with trying to enhance dopamine in people with what we call anhedonia, which is the lack of pleasure, aspects of the pleasure system that are impaired. That's one thing. We also have a completely different way of using music to help people with hearing loss. So hearing loss is another problem that is very prevalent, especially with aging, right? Everyone has some hearing loss. And so what we are developing is, and by the way, people with hearing loss often they will use hearing aids, but the hearing aids they're okay for hearing conversation, but everyone who has hearing aids says that music sounds horrible because it distorts the sound. It doesn't really work. Um, so what we're working on now is a glove that you put on your hand and it vibrates based on the frequencies of sound of music. And so the idea is that we will be able to enhance people's perception of music by letting them hear music through whatever is left of their hearing, and then giving them an extra boost by wearing this glove that gives it the vibration. And this is a really interesting thing. And it's sort of based on um, observations that people with hearing loss have told us. If you talk to people who are deaf, profoundly deaf, many of them actually, surprisingly, say that they enjoy music. And when you ask them, but what do you mean you enjoy music? You can't hear it. What they tell you is, oh yeah, but I go to dance clubs, right? And I stand barefoot on the dance floor and I feel the vibration through my feet. And then I can dance and I, I, I enjoy music. So if you can do that, then maybe, you could help uh, people with vibration on the hands, which are even more sensitive than the feet are. So that's a new direction.
What's the most important thing you'd like people to understand about the relationship between music and the brain?
Based on the studies that we've done, we now have an understanding of how music acts upon the brain that we didn't have 20 or 30 years ago. And sometimes people will say to me, "Oh, but you know, you're taking all the mystery away, and it's going to decrease my enjoyment of music." And I always say to them, "No, I don't think so. Really, it should be the opposite. When we understand the biology behind it, it's even more awesome. It's even more amazing that we have this thing called music that activates these ancient parts of our brain, right? These are like parts of our brain that in evolution have been around for millions and millions of years. And we can actually regulate our emotions and our well-being and our state of mind and our moods. We can do all that by music.
Yeah.
And now we understand how and why that works. And to me, that makes me appreciate music even more. I mean, I'm a music lover. I have been all my life. The more I study it, the better it gets
Yeah.
in a
The more
way,
you understand it, it's like the more you understand the brain, the smarter you are.
That's right. Like I have a colleague who says it's a little bit like if you study astronomy, when you go and look at the night sky, it's even more amazing because you look at these bright things and you realize this star is, 100 million light years away, and that one is not a star at all. It's actually, an asteroid. And you get a deeper understanding of it, and your awe of the universe is much greater because you understand it. And similarly, I think, we stand in awe of biology that now that we understand more about it, um, I think it makes it even more valuable. And I've talked to a lot of musicians, people like yourself, who are kind of on the same side as I am. They're fascinated by the fact that the musical brain is a reality and that it's something that humans can do and all of the complexity of it, right? So it's not something trivial. It's something very profound that is part of our biology, um, and that, enhances our lives.
What advice would you give musicians and music lovers who want to learn more about how music affects our minds?
One thing I could say is that if you are a musician, you might ask around, any universities that are near you because many music departments at universities are now partnering with people like me to develop, different technologies or to do research, also to do research, for example, on musical training, like what's the best way to train people, what's the best way to train children, what's the best way to train adults, um, to try to understand, why some people are better at singing, whereas others are better at playing a string instrument, and still others are better at drumming.
So it's all
So all
that.
those things. Yeah. So, if you look around at any major university, it's very likely that there will be people who are musicians, but who are also somehow engaged with or interacting with scientists. In fact, a couple of my former students are actually employed in departments of music, or like I mentioned, my former student who's working for the Philharmonic Orchestra in Paris, which is an amazing
Yeah.
position. Every time I go visit her, I get to hear the whatever's playing at the Philharmonie de Paris. It's spectacular, and she's working with musicians every day, right? Um, and I have a colleague at Stanford who is a scientist who studies brainwaves actually, and she was hired by the Department of Music at Stanford. So, I think the people in music are very receptive to this, which again is very rewarding because it means that we're doing something that maybe we're on the right track, having engaged musicians into our and they help us too because they give us insights that we might not have. I mean, I have my own insights as a not so great musician, but if you talk to musicians who are professionals, they have all kinds of hints, like what you were saying about being able to memorize a piece of music. Um, what are the techniques to help people memorize music? There's a lot of interest in that.
So we could get
Good.
your book from Perception to Pleasure on Amazon. Now, I know you've also done a couple of other books as a collaborator, I believe.
Yeah,
You
yeah.
want to
Those are
mention
more
that?
science books.
Okay.
I've also got a couple of YouTube videos that people can watch. Um, and there are many labs throughout the world that work on music and the brain. If you do a little bit of searching, you'll find, there's a group in Denmark that I have a lot of connections with. It's called the Center for Music in the Brain. It's actually run by a guy who's a scientist, but is also a professional jazz bass player.
Well, I want to thank you so much for your time. This is very interesting.
Sure. Well, thank you
Um,
for picking it up.
and thank you again so much. Keep up the
Nice
good
to
work.
nice to chat with you.
Yeah, it's been a
Okay.
pleasure. Thank you so
Take
much.
care.